while we wait for Ben, what we're going to do today is first we're going to go over some content, PowerPoint, and then we're going to explain an activity, and then we're actually going to be going down to the Fab Lab, and we're going to check that out. So first we're going to talk about controlling mechanical power. Some advantages of controlling mechanical power. You can switch it on and off. For example, like a clutch in a car. Two types of clutches, friction and centrifugal. You can change the direction. Gears can cause it to, you can put it go forward or go reverse. You can also change its force and speed, obviously. So gears, as most of us probably know, are wheels with teeth that mesh with other gears. Force is transferred from the shaft through the hole in the center. Changing the amount of teeth on the gear or the size of the gear can affect the speed and power. Speed and power, not seed and power. So in order to do that, we have to figure out our gear ratio. We do that by dividing the number of teeth on the driver gear divided by the number of teeth on the driven gear. The driver gear is the one that's directly connected to the power source, and then the driven gear is the last gear that's in a system. Other ways, pulleys and belts, kind of the same concept, only it's like a metal disc that connects with a belt. Sprockets and chains, kind of the same thing, and then again, clutches. So now we're going to get into some separating processes, specifically machining. Machining, it removes material in the form of a chip. And two things that you need to consider when you're machining is the feed rate, how fast the tool is actually moving across the object, and the cutting speed, and that's like how fast the cutting tool is moving. Types of machines, milling machine, probably all seen a mill. Drilling, turning. Turning machine, it's the only type of machine where the workpiece is actually rotated against a stationary cutting tool, and that's how you remove material. Shaping, and then a planing machine. And then this is just kind of an FYI, some non-traditional machining. Electric discharge machining uses electric sparks to make a cavity in a piece of material. Laser machining, it uses intense light from a laser to remove material. And what's cool is you can use like a mirror, and you can actually bounce it off and then cut material off around the corner. And then in chemical machining, it uses chemical reactions to remove material. So, okay, so specifically what we're going to be using today is the laser engraver down in the Fab Lab. And just some insight about the laser engraver, just some benefits and uses. It's you use computer software. You can generate images, designs, letters. You can also cut stuff out. It's very accurate, and accuracy is the closeness to the desired outcome that you want. And it's also very precise, and that means that it's able to make multiple parts exactly the same. And measurement is going to be very important, and you guys will find that out today, how important it is. It's very quick compared to if you were to try to do what a laser can do. If you were trying to do that by hand, it's not even comparable. It can be used for aesthetics. You can make something look pretty, and it can also be used for separating material. Many different materials can be used in a laser engraver as well. Here's just some examples. Raster cut is used to, that's kind of acts as like a normal printer. It kind of makes something look pretty. And then a vector cut, you can cut stuff out.
What kind of machining is laser engraving?
Not traditional. Does that answer the question, I guess?
Yeah.
Okay, so for our purposes today, our activity, we're just going to go over some reminders about geometry. Circle, the radius is from the center point to the outside edge of a circle. Diameter is 2 radiuses. It goes all across a circle. And a chord is just, it's a line segment that touches 2 outer edges of a circle, but it doesn't pass the center point.
Outer edge.
Is that
Outer or inner? Go back to your slide. The outer or inner
what?
edges.
Chord. I would say outer.
Oh, I'm just asking. Your slide suggests inner.
Oh.
You
Well,
know,
well, compared to a tangent line would be the outside. Just a tangent line touches a point on the circle, but it doesn't cross it.
okay.
So that would say that would be probably here then. Okay. Now we have to, for our purposes, we have to consider tolerance. Once we figure out the activity, we're just gonna keep this in your heads. Tolerance is the allowable variation for any given size in order to achieve a proper function. It equals the difference between upper and lower limit dimensions. So then, today we want to be as accurate as we can when we make our measurements.
Alright, so the activity we're going to do is we're going to build a car with cutting out a laser engraver, and each of you guys are going to break up into pairs. We're basically just going to do the pairs that you guys have for the groups, so you don't have to waste that time trying to figure out who's your best friends and all that. So we're going to give you a packet. We're going to give you a kit, basically, and it's going to have a ruler in it, it's going to have your wheels, it's going to have your axles and then your gears, and then a motor, and then it's going to have a compass. Everything is going to be explained how to use it in your worksheet packet. And then we're going to assign each group either if it's going to be designed for power or it's going to be designed for speed. So then once we assign it, you can just circle number 1 basically right here, power or speed. Alright, so we'll hand out your kits and then we'll go down to the Fab Lab. So make sure you judge yourself. Does everyone have their safety glasses today? Not this one, but we'll use them. Well, they're all basically the same. So this is the laser engraver we're going to put our pieces on to get to that point. I just want to explain how it works and everything. So basically, what is the laser engraver again? What kind of machine you use it? And why would you use a non-traditional machining? What's some of the advantages of that?
No contact, no contact in workpiece, so it's the time to wear it.
It's more complex, it's more accurate, precise. So basically, alright, so what we're going to do is we're going to put our pieces in there and it's going to cut out the rayon and eventually we're going to put it in there, and there's certain parameters you have to put because you have to change your cutting speed and your feed rate basically, or your intensity of the laser. So for different materials, we have different kind of cutting speeds. You can just look at this template. And if you can't find it on here, usually there is, just type it online, what is the cutting speed and or what kind of use laser engraver for leather or something like that. You know, find something online. What we do is we go with our draw, start off with.
You guys see over there?
Turn the volume.
Absolutely.
And if you've ever been certified in Fab Lab, you use like that. You have training all the time. You just ask one of the Fab Lab assistants and you set up for it. Then what we do is open a document and say,
If you want to get up there and close. You probably just see the screen.
start from news. And then we have to specify the parameters of our document size. So we'll just say 15 by 50 is good for us right now. And here's our workpiece. And then what we do is import our image.
Or put it together and closer so you can see.
So we go File, Import, and then we just find an image on here. See if this opens on here. So right now I just have these two basic lenses. This is from a previous project I have. And what I'll do is put there, it's on, and then what you're going to do once you're ready to print is hit File, Print. And then you have to go over to the preferences over here. You have to change your workpiece because right now it's set to 8.5 by 11. And you just match it up what we have up here for our workpiece, which was 15.5 by 6. And then like you said, look at this, change different things. And like you said, there's different ways for cutting on the laser grader. There's vector and raster. Vector will cut out the workpiece, so it is a separating process, and then raster is basically drawing on it. So, and you can choose between those, raster, vector, or combine. The one thing you have to do, though, if it's going to be a vector cut, is change your lines to a hairline.
Yeah. I get the right angle.
There you go, found it. Oh. Yeah, change it to hairline for a vector image. So this will basically cut out in our piece the lenses, and then these right here will be etched in because they're not hairline. And so yeah. And then one other thing when you're doing vector cutting is you have to turn it on the valve right here. Turn it on, because when you do vector cutting, there's going to be some fumes that are going to come up, so there's the smokes back there and bring them up there. So once you guys are done with your packet, you would come to me and then we'll cut out your pieces. So get in your groups right now and
We'll go through the packet.
check, yeah.
What kind of line do you use for a vector?
Oh yes, driver over here.
Turbo to gear ratio. So driver is 15, so it's 1 to 3.
Okay.
So then, design a car that will be able to perform the task as assigned to you. Placement of the motor determine the wheel or the wheel axle will need to be placed.
Oh.
So that's that's going to be a little nicer.
Yeah, yeah.
Speed, right?
15 more 45. There.
Driver gear divided by driven gears.
You're going to assign.
I do.
You did assign.
Yeah, I already said it.
45 level 15.
We need to use the ruler.
Oh, we do? Ruler.
Diameter of the two gears. Mr. Pepper, question. When you're talking about the diameter of the gears,
Drive gear.
We want speeds with a big gear being driven.
Yeah.
Driving.
Yeah. So what is it? It doesn't say it.
If you went half down, that'd probably be a safe bet. Then when we go to compass, stick our head and
Task your sign. Because in order to determine where the wheel axle will need to be placed.
So is this X?
That's where I think it's your motor. Okay. And that, I guess. Represent one.
average them out.
Yeah, where'd you measure it from? You measured from outside to outside?
Yeah, I measured, well, we wrote them both down and then I just averaged them. So I measured in the center of them.
Okay. Well, as long as you, the thing is when you give it to me,
Yeah.
as long as you give me measurements, I would be able to plug them in. Wherever you measure it, it's going to be a little bit.
Yeah. Okay. Then that would be like 17, 30 seconds.
Let's do the quick thing.
Yeah, we tested that. Shaun
See,
came
so-
over.
Yeah.
You want to work out?
Yeah. Okay.
Alright, so basically this is a CAD program. This is how we're going to enter our stuff into our version paper. Alright, so. How high was your appeal? Did you measure that?
Oh, we didn't measure the X, we just measured that one.
Did you say
We need to measure the X as well. We can go do that.
okay?
So from the bottom to the X,
From the bottom to the X.
we have 1 3/8 inches.
Okay.
And then to this side, we have 1 3/16.
Alright. So where is your bottom placement then?
The bottom placement we have at it is up 17-30 seconds. And it is over 15-30 seconds.
Does that look about right?
Yeah.
Alright. So we're going to have those two holes that are going to be right there. Can you put the motor on?
Yep.
We're going to have to flip them over. Because we don't want those two holes in there.
1 inch. You're gonna mirror them?
Yeah.
Oh, we're gonna have to find out.
Alright, so it's exactly like yours, kind of?
I would say so, yeah.
Alright, so this guy.
You did this in last year, you have one too?
Yeah, we would have, this would be after you have CAD instruction. And that's also why it's another part of it. If you guys all knew AutoCAD, we wouldn't even be doing this.
Yeah, you do know.
Yeah, exactly. And that's gonna be a little bit of instruction wrap up at the end.
I'd say it's a good thing to put in your testing.
141. So we got some time. They don't take long to cut all. They won't take long.
Alright.
It's up to this semester.
Apparently we're making a Hummer. Mr. Instructor Man, do we take off the plastic on the plexi?
Yes, that would help a lot.
If you're still inclined, try to be easier to drill. Yeah.
Oh, wonderful.
It's going to auto focus first.
Yeah.
One of the holes is like,
It cuts right.
Laser's focusing. Now it's going There you go. Alright, next group, who is second?
Yeah, who was second?
No, that's
What?
Well, that's the fan or the vacuum. It's just dragging on.
Yeah, that should be.
That's why it's rubber, not metal. I think so. Sorry.
What?
CNC, you're talking about.
Why would a manufacturing company want to use these?
Quick, fast, precise.
Quick, fast, and precise? Good answer.
you're getting all the parts at once.
Minimize your weight. Yeah, all you gotta do is take it out and assemble it.
Right.
We lost the line.
Alright, so poke them out like that and you're done.
Yeah, go ahead.
What about that one? That line. Shouldn't that line be there?
Or we could
All in
just.
all, that was 2 minutes. For a kidney scanner for 2 minutes, that's not so bad.
Look for Shaun. How do lasers work?
Intense beam of light.
How is it focused?
You ever take magnifying glass and burn ants in the summertime? The light gets focused to small point that is actually hot enough to turn into ants.
No, I'm a modern day kid that's only played PS3 and really never heard that.
You ever play video games like burn ants? There might be an ad. But that's how your question's answered.
There's the kid to hold your iPod to the side of the camera flash melts it.
I think it's probably players like that.
I've never burned ants.
I don't know if we're trying to do ants.
What about any other kind of material?
That's the app we need to make. Sun and just your flash is turned into a laser beam. It's starting like bubbles in the machine.
Alright.
Go.
Thanks for fixing my roof.
Go see if we can do that.
That's an art student.
Is that all that needs to be in there?
Yeah, that's good enough. For our purposes.
I feel like that's going to restrict the...
Take the motor back up now.
What's that?
Yeah, you put it before spot.
Nobody told us that.
Yeah, we didn't.
There was no instruction.
We mixed that. Now go ahead and put it together. That's real. You go ahead and you glue up these pieces.
Well, I need somebody to hold it. That's the key. Do I glue on the inside or the outside? They're the
However
same
you can get
size.
it, however you can get it to stay together.
So I'm doing like this. Now, Justin, which way are you doing this? You're going this way, so okay. You're doing the right side. I'm doing the left side.
Okay. I feel like we should put something underneath.
Let's do it.
I'm not going to make you upset about the fat that time.
It's like you do, man.
I'm going to put on the roof.
Okay. Then I get this one on.
Is that on windshield? The hood.
We have no windshield.
Okay?
You line up the front, I'll line up the back.
Okay.
Power. Power. Power.
All the whole beam.
Let's spot up top now.
Okay. Bushings. Are we better off just running this one without the bushings?
No,
Or at least on this side?
we'll just see how it fits in there.
Okay.
Might get some flex out of it.
That's not gonna turn, is it?
That's really good. I'm just gonna pop it in.
We'll see if we can pop it out and see how it fits. Little loose.
Maybe.
Maybe.
The bushing on the outside rather than the end. Yeah. Throw off our gear placement.
Oh yeah, where's the next bushing? Maybe?
Yeah, now if this gear can ride.
Might want to take off the. Yeah.
Yeah, put it on the other way. A little tight. Did you measure from valley to valley on your gear? Or did you compensate with your compass?
Compensated with compass. Might be right there. Got it, Mr. Pepper.
Oh, that's gonna take
Does
a
it
lot
turn?
of torque. Ah. Glue gun. Yeah, that's not
Knowing
gonna
what
work.
you know about the accuracy of the laser engraver, what do you think is problematic by how we designed
We need
this?
more accurate tools to measure.
Exactly. We didn't even take advantage of the fact that we can get such accuracy out of the laser engraver. Because we used a wooden ruler to make our measurements.
We should get calipers.
Should.
Well,
Use
this
calipers, or we can get a puddle CAD and we can see how it lines up with our measurements there.
That's quite true. This was terrific lesson. I'm supposed to think of college.
I don't know if we're going to get like 3 more done.
Yeah.
3 more done. I don't think they will.
Well, that was fun.
I think it would drive, Sean.